All right. Okay, so on today's videos, we'll get to look at measures of dispersion. All right, that's what we're going to look at. So under measures of dispersion, we're going to first look at what we term the range. All right, the range. So how do you get to calculate the range? So when you're calculating the range, all right, this is the difference between the highest and the lowest data values. That is the range. It's the difference between the highest and the lowest data values. So when you're finding the range, you look for the highest value, all right? You look for highest data value minus the lowest data value. All right, so the range is the difference between the highest data value minus the lowest data value. That's how you get to find the range. So let's see if we can look for an example on how we can find this. Suppose I have this data. All right, suppose I have this data. How do I get to find the range? So of course, I need to rearrange this so that I know which one will be my smallest data and which one will be my highest. So far the smallest is 8, all right, followed by 9. Then we have 10, 11, 12, 15, and 18. So our smallest data is 8 and our largest or highest data is 18. So when we are finding the range, we say 18 minus 8. So our range in this case, we have 10. All right, what about for this one? All right, we have 17, 18, 5, 25, 1, 16, 20, 8, 20. So if we're finding the range, all right, we can simply say, all right, so the range, if we look at for the highest value, we'll get 25, right? 25. So we're going to say 25 minus the smallest is 1. So our range will be 24. Okay, that's more like it. So quickly, remember we are looking at measures of dispersion, right? So one might wonder to say, what is measures of dispersion? So when we are looking at measures of dispersion, it gives us information about how spread out, all right, or how close the data values are in the given data set. All right, how spread out or how close the data is in a given data set. So we have already looked at the range, all right, and we have just seen how you can find the range. You say highest data value minus the lowest data. Let's take it to temperature. We have on our data, we have negative 19 degrees Celsius, so-called 0 degrees Celsius. This one looks like 0 to the power x, 0 degrees Celsius, 31 degrees Celsius, very hot, negative 15 degrees Celsius, negative 2 degrees Celsius, yo, somebody's freezing. So, what's happening is with this data that we have, what is our lowest? Our lowest is negative 19, all right, negative 19 degrees Celsius. And our largest is 31 degrees. So the highest data value is 31 degrees and the lowest is negative 19. All right, so how do we get to find the range? So we're going to say the range is equal to the maximum or the highest data value minus the lowest data value. So now answer will be 31 plus 19, and our answer will be 50 degrees Celsius. That is right. So the previous one we are from looking at is the range. The range. Now we're going to look at the quartiles. So for the quartiles, it divides the ordered data set, data set into 4 equal parts. All right, or 4 equal quarters, right? So when we talk about quartiles, it divides the ordered set or data set into 4 equal parts. So we get to look at that. So the other part, so this quartiles has been categorized in lower quartile, lower quartile, then we have the middle, okay, the middle quartile, then we have the upper quartile. So the lower quartile get to divide the lower part into two halves. Then the middle quartile get to divide the middle part into two equal halves, right? And then the last part, which is the upper part, divides also the top half of the data set into two equal halves. So that's of the quartiles. So we get to look at examples on how you can find these quartiles, and then we jump right in and get to understand it clearly. All right, so we have this information saying the heights of 10 students were recorded as follows. We have 176 centimeter, 180 centimeter, 159 centimeter, 152 centimeter, 168 centimeter, 156 centimeter, 166 centimeter, 151 centimeter, 168 centimeter, 161 centimeter. Remember, I would say that these quartiles are divided into 4 equal parts, all right, with the well-ordered data. So we start with the smallest. What is our smallest height? Is this one. So we have 151 centimeter, followed by 152 centimeter, followed by what we have, 156. Is that so? Yeah, 156. We have 159. Then we have 161. We have 166, 168, 176, and lastly 180. That's supposed to be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Which one did I forget? Oh, there are 2 of 180s. Okay. 168, sorry, 168. There are 2. Let me just write this so that, all right, that's more like it. So now we get to divide this into 4 equal parts. Because the question that we have been asked to find is saying calculate. All right, check. Saying calculate the values, the value of Q2. So for Q2, this is our middle quartile, right? Q1 is our lower quartile, and Q3 is our upper quartile. So for us to find Q2, we need to find the middle or the median, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1, 2, 3, 4, 1, 2, 3, 4. So this is where our middle part is. So for us to find the middle part, we get to add 161 plus 166 over 2. All right, so Q2 is equal to 161 plus 166, and we are going to get 327 over 2, and that will give us 163.5 centimeter. So this middle quartile is right here. All right, then the next question they're asking us now to find the lower quartile. So now how do we get to find lower quartile? Because now the line has, we have already divided this. All right, so we have divided this part, meaning that our lower quartile will be now divided out of 1, 2, 3, 4, 5 data values. All right, so for us to find the lower quartile now, it will be this one, 1 plus 1 plus 1 plus 1. So its half is this one. That's where our lower quartile will be. All right, that's where our lower quartile will be. So we are going to simply indicate, say 156 is our lower quartile. And the reason why we have to divide this one, because we are 2 at the middle. So for us to find exact the middle value, we have to add this, then divide by 2, so that we know what value was between 161 and 166. All right. Then if we find the upper quartile, right? If we're finding the upper quartile, what we're going to do now is we do the same. Even here, the data values will be 5. We have 1, 2, 3, 4, 5. So our upper quartile is 168. All right. So we have this data set. Right. So from this data set, we have been asked to calculate the middle quartile, the lower quartile, and the upper quartile. So what we need to first do is arrange this in order, starting with the smallest all the way to the biggest data value. So 1.9 is our smallest, followed by 2.6, then we have 3.7, then we have 5, then we have 6.3, then we have 6.4 right there, then we have 8, then we have 8.8. We have 1, 2, 3, 4, 5, 6, 7, 8. Nice. Now that we have rearranged this, so we have 8 in total, right? So 1, 2, 3, 4, 5, 6, 7, 8. So for us to find the middle quartile, that means the middle value. So we have 1, 2, 3. It's at this point 3. Then here 1, 2, 3. This point here. So our middle part, we have two things. All right, we have two things, 5 and 6.3. So for us to find the middle quartile, we need to add that 5 plus 6.3 over 2, because now you need to find that's where our Q2 is. All right, because now we have 1, 2, 3, 4. Even here, 1, 2, 3, 4. They have been divided into 2 halves or 2 halves. All right, so our middle quartile is equal to, we have 5 plus 6.3, we have 11.3 over 2. All right, so Q2 we are going to we'll get something like 5.65. Yes, this is our data for the middle quartile. Then there's another question for the lower. So for the lower quartile now, for the lower quartile, we are now getting it from the 4 data values, 1, 2, 3, 4. So if we want to find the lower quartile, is here, which is 1, 2, 1, 2. So our Q1 is right here. So we are going to add this one plus that one so that we know what T is at Q1. So for Q1, we are going to say 2.6 plus 3.7 over 2. What is our Q1? We are finding 6.3, yeah. 6.3 over 2. Then what is 6.3 over 2? We're going to have 3.15, because 30 is 15, so it will be 3.15. This is our lower quartile. So now let's jump in and find the upper quartile. For upper quartile now, we also do the same. 1, 2, 3, 4 is right here. That's why we are saying that quartiles divide the data values, the ordered data values, into 4 halves. So we have 1, 2, 3, 4. All right, so we have 4 halves. We have 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 3, 4. So how do we get to find the upper quartile? For the upper quartile now, we are going to say Q3 is equal to 6.4 plus 8, right, over 2. Then we have 14.4, right? We will get 14.4 over 2, which will give us 7.2. 7.2 is our answer. Okay, let's go a step further. Now we have the interquartile and semiquartile. So when you're finding the interquartile, which is denoted by IQR, because yeah, that's IQR, interquartile range. Let me include range and semiquartile range. IQR. All right, so for the interquartile range, how do you get to find interquartile range? So for you to find interquartile range, you say upper quartile, which is Q3 minus lower quartile. Just like the way we're finding range, but for range is the highest data value minus lower data value. But for interquartile range is that we get the upper quartile minus the lower quartile. So like from the data that we're just from solving, yeah, we found that our Q3 is 7.2, Q3 is 7.2, so it's a minus. Well, our Q1 was 3.15. All right, so if you get to subtract that, we are going to get a 4.05. 4.05. This is our interquartile range. So we got that. We got the 7.2, which is our upper quartile minus the lower quartile. Then you subtract, you get your interquartile range. All right. Then for semi-quartile, semi means half, right? So half interquartile range. So for semi-interquartile range, we just have to divide our quartile by half. So we get this information, or rather, we get this formula. So for semi-quartile range, you get half of interquartile range. So if we divide this one by half, we find the semi-interquartile range. All right. So what we have here is saying for the data set 10, 17, 9, 15, 12, 11, 20, find the lower quartile. So before we jump in and start finding, we need to rearrange this, all right? So we'll start with the smallest all the way to the biggest. So what is our smallest? 9. Followed by 10, we have 11, 12, 15, 17, and 20. So just to check, we have 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Awesome. So here we have 17. All right. So for the lower quartile, yeah, for the lower quartile, it would be very wise for us to identify first, the middle quartile, yeah. So we have 1, 2, 3, 4, 5, 6, 7. So just for the data collection purpose, our middle quartile is equal to 15. 12 is actually 12 right here. 1, 2, 3, 1, 2, 3. So it's 12. Now that we know our middle quartile, it's very easy now to find the lower quartiles, because now we can say on our first part or lower part, we have 3 data values, 9, 10, 11. So our lower quartile is 10, so I have 1, 1. So our lower quartile is 10. Then for upper quartile, we have 3 data values as well, 15, 17, and 20. So our upper quartile is 17, like that, right? This is how you get to answer such questions. So A, we have found our lower quartile, which is 10, and B, our upper quartile, lower quartile is 10, upper quartile is 17. Now let's check out the next video as we get to find interquartile range.